Hi guys, this is Max Mayo from Period 1 with Mr. Farrar, and today we're going to be doing the 2008 AP Calculus problem, number 5, and I'll start it right here. So the first thing it's asking us to do is to consider the differential equation and on the axes draw the slope field. So I'm going to start by drawing a slope field. And this takes just a couple seconds. So we're drawing the slope field for the equation dy over dx equals y minus 1 over x squared. So the slope field for this equation, I'll draw it out really quickly, but all of you know how to do that. So here's the slope field for y minus 1 over x squared, and that's the first part of the question. So the second part of the question is going to be find the particular solution y equals fx to the differential equation with the initial condition f of 2 equals 0. So the first thing we're going to do is separate this and put the dy with the y's and the dx with the x's. So y minus 1 dy, 1 over y minus 1 dy equals x squared dx. And now we're going to integrate both sides. So using our natural log integration, the natural log of y minus 1 absolute value equals negative 1 over x plus c for the entire equation. And we get that from the rule 1 over x equals, the integral of 1 over x equals natural log of x. So moving on, we now are going to raise both sides to the e. And that's going to get rid of our natural log. So we're going to have y minus 1 absolute value equals e to the negative 1 over x plus c. Now what we're going to try to do is move this one over and isolate the equation so we can make the complete equation. So y minus 1 equals e to the c, e to the negative 1 over x. This is just moving, separating that the e's over here. And then y equals e to the c, e to the negative 1 over x plus 1. And now what we're going to do is, because they told us initially that f of 2 equals 0, we're going to plug in f of 2. So to find what this number is, which we'll call e to the c equals k. So y equals k e to the negative 1 over x plus 1. We know that when y equals 0, x equals 2. And then we know by isolating this, k is going to equal negative e to the 1/2. And you can just get that from moving this over. So once we know that, we can plug everything back in and get f of x equals 1 minus e to the 1/2 minus 1 over x. And that's part B of the. Okay, so now that we've done part B, the bulk of the problem, all we have to do is find the limit as x approaches infinity of the function. So to do that, our function is sorry guys, the limit of x going to infinity is 1 minus e to the 1/2 minus 1 over x. So to find this limit, you plug in e to infinity, infinity to where x is. So that's going to be 1 over infinity, which is an infinitely small number. So this is going to go away. And the answer is just going to be 1 minus e to the 1/2. And that's our limit. And that is our problem. Thank you, everyone. And that is 2008 AP question number 5.